In this proof of concept, Wireshark was installed on a Windows VM, and malware traffic analysis was conducted using Wireshark. Exporting files from HTTP traffic. In this demo, the tutorial pcap 1 of 5 is opened in Wireshark. After filtering on HTTP request, we can find the GET requests, one request ending with .doc, and the other ending with .exe. We can export the files from the HTTP object list and save them locally on our computer. Select the first line with invoice and MSO request.doc as the file name and save it. Select the second line with knr.exe as the file name and save it. Transfer the files to your Linux client. In this demo, Kali Linux is used, but it could be any Linux client. Run file invoice and MSO request.doc to identify the file type. Run SHA-SUM-A256 invoice and MSO request.doc to calculate the hash of the file. Repeat the same process for knr.exe. Run file knr.exe and run SHA-SUM-A256 knr.exe. This confirms the suspected Word document is a Word document, and the Windows executable is indeed a Windows executable. We can check the hashes against VirusTotal to see if these files are detected as malware. We can also extract web pages from unencrypted HTTP traffic. Use Wireshark to open the tutorial pcap 2 of 5. Export objects from HTTP and save everything locally in a folder named PayPal. Navigate to the PayPal folder and open WebSource HTML file with Firefox. This should reveal a potentially malicious PayPal login page. Exporting files from SMB traffic. On the tutorial pcap 3 of 5, export objects from the SMB. 2 entries have file names indicating Windows executable files. Save these Windows executable files. In this demo, the files are named sample1.exe and sample2.exe. Open PowerShell. Navigate to the directory where the Windows executables are saved. Run the command get file hash sample1.exe -algorithm SHA-256 to calculate the hash value of sample1.exe. Repeat the same process for sample2.exe. Exporting emails from SMTP traffic. Open the tutorial pcap 4 of 5. Apply the filter SMTP data fragment. This should reveal 50 examples of subject lines in the info column. Export objects from IMF, which stands for Internet Message Format. IMF files have a .eml file extension. Save one of the EML files locally to your computer. The exported .eml files can be reviewed with a text editor or an email client like Outlook. Exporting files from FTP traffic. Some malware families use FTP during malware infections. Open the tutorial pcap 5 of 5. Apply the filter ftp.request.command or ftp data and tcp.seq-eq1. We should see user for the username and pass for the password. This is followed by RETR statements, which are requests to retrieve files. Export objects from the FTP data channel. This lists all of the HTML files sent to the FTP server containing information stolen from the infected Windows host. Save all files into a folder named ftp_sample. We can view the exported files in a text editor or a web browser. These files contain login credentials from the infected host's email client and web browser. While the export FTP data function works for the .html files, it did not present us with any of the .exe files retrieved from the FTP server. We need to export these using another method. Apply the filter ftpdata.command contains .exe and tcp.seq-eq1. The results show an FTP data stream for each of the .exe files. We can follow the TCP stream for each of the frames and export these files from the TCP stream window. The TCP stream window shows hints that this is a Windows executable or DLL file. To export the file from the TCP stream, select RAW in the Show As menu. We can export this raw data as a file using the Save As button. This is an FTP data stream for a file named q.exe, and we need to manually type that when saving the file. Transfer the file to your Linux client. We can confirm that this is a Windows executable file and get the SHA-256 hash by running the file and SHA-SUM commands. Copy and paste the hash onto VirusTotal. This hash shows a high detection rate as malware on VirusTotal. TShark is a terminal-oriented version of Wireshark. If a pcap is larger than 500 megabytes, Wireshark will struggle to analyze it. For example, let's pretend that tutorial pcap 1 is a large pcap, and we are interested in the IP address 23.63.254.163. We can run a filter in TShark and output it into another pcap named new data. We can verify that TShark has produced a new pcap with 9 packets, filtered by the IP address we provided. In this proof of concept, we successfully conducted malware traffic analysis using Wireshark. We demonstrated how to export files from various types of traffic, including HTTP, SMB, SMTP, and FTP. We also showed how to leverage TShark to filter specific values and export them into a more manageable pcap. With these techniques, you can streamline your traffic analysis and uncover hidden threats more efficiently. For more details, refer to the Cyber Defense Kit documentation.